Hey guys, welcome to DevOps School. Kubernetes is one of the most popular technology in cloud computing as of today. Learning Kubernetes is essential for any DevOps professional, and one of the most in-demand certification is Kubernetes Administration. In this session and in this series, we are going to learn various aspects of Kubernetes Administration, which will help you to prepare for the Certified Kubernetes Administration exam or CKA exam. This series is divided into 20 parts, therefore subscribe to our channel and follow the playlist for complete understanding.
So today we are going to talk about services. What is services? So far we discussed many things. We discussed about what is Kubernetes. We discuss about why do we need Kubernetes. Then we discuss about the architecture of Kubernetes, in which we discuss in detail about the master. Then we discuss about nodes, and then we discuss about what is a pod, replication controller, and deployment. Now this is the services. So we will discuss about the services. So think about it. In your infrastructure, in your cluster, Kubernetes cluster, you have so many pods running. Let me remind you, if you forgot, pods may run in any node, okay, and pods get their own network, so a own IP address, their own network coordinate through pod networking. So the question is, how can you access a group of pod for the end user? Okay, so how can you access? Of course, you need a load balancer. So this is what we are trying to discuss. So let's understand what is the services. So in order to understand what is services, let's understand this picture here. Here you have a 6 node.
We just started, right?
Yes, we just started.
Okay.
So here we have 6 nodes: node 1, node 2, node 3, node 4, node 5, node 6. Now you see each node you have a pod, okay, and pod has an IP address. You might also see if the one pod is gone, another pod will replace and the IP address will change. You also might want to see that here pod has a container, and container, some container, the images which is front end, and some containers are back end. Okay, so this is the behavior, this is the implementation you might be having in your Kubernetes cluster. Now the question is, how can you access these pod? So maybe you want to access, now you have, let's say, 4 front end and you have a 3 backend. How this front end will communicate with the backend? And backend means a DB. Okay, because here you have a 4 front end, 4 FE, and 2 DB, let's say. So look at this image here. Now which front end will talk to which backend? This is the one problem what you have, because it might be chances like, yeah, can you, yeah, so which backend? So here you have a pod, 4 pod from the front end, 2 pod from the backend. So which front end will talk to the which backend? That is the question. That is an important question what we have. So there is a challenges here. Now you want to scale up number of pods. So when you want to scale up the number of pods, you get new pod. Now new pod, new IP address, and you might also want to upgrade the images inside the pod. So here you have a DV v1 and then DV v2, v3. So v2. So basically 2 pods for the backend, it got changed, and then 1 pod is remain same. So here there is a bad thing which is happening. Now sometimes the front end will drive the traffic to the v1 and then sometime v2. In a simple word, if I put it, sometime you see log into Gmail, you'll get a 50 emails, and sometime you get 100 emails. That is not good, right? So how to fix these issues? How to fix this? The first problem is how to manage the traffic from the front end to the back end in, in average out the traffic, and only one of the pod should be available and the traffic should be even. Okay, it should be balanced. Okay, and then same time, if the new pods get added, then automatically they should be balanced. Third problem is if the pod is having the new update and older update, it should all the pods traffic should be redirected to the new pod. So how can you fix this kind of issues? How can you fix it? The answer is service. Okay, so answer is service. Service is basically your load balancer in your Kubernetes cluster. Service is, again, I'm saying, is a load balancer in your Kubernetes cluster. So what you do, you create a service. Okay, service का load balancer. Service when you create, managed by the cluster, Kubernetes cluster, and service IP address never change. Service DNS name never change. So now in this case, if you see here, you have a 4 pod. Now 4 pod hitting to the service IP address. Now service decide which pod the traffic will be transferred. So that responsibility is beneath with the service. So here service will drive a traffic to the pod 1 or pod 2. Okay. Now service automatically get added. Service, if the new pod get added to the same nature, service automatically update and automatically started load balancing. How it is automatically started load balancing, I'll discuss in some time. Okay, but that is the service. So even the new pod comes, service will detect those new pods and then start diverting the traffic to the new pod as well. Okay, now there is a problem here. Look at this. Service is service has a 4 pod. 2 pod is a V1. 2 pod is V1.2. Same problem which we had discussed earlier. One is deployment and another one is a new deployment. So now you have a 2 different kind of containers and pod running and resolving to the same service. So this is not good, right? This is not good. So how can we solve this problem? How can we instruct service to drive a traffic only to 1.2 or V1 based upon the requirement? How can we do that? Okay, how can we fix this problem? That problem can be solved out by labels. Okay, so now labels is nothing but is like a guide kind of naming any object in Kubernetes you create. It's like giving a name, but name which is unique, you cannot use the same name again and again to the any object you create in a Kubernetes in the same namespaces. But labels, you can use it multiple times. One object you can give multiple labels, and same labels you can apply to other objects as well. So let's understand how it works. If you look at this here you have a service, and service labeled with prod B1.3. Now if you look at the pod also, pod is also labeled with prod B1.3, prod B1.3, prod B1.3. If you look at very carefully, pod to pod, which is at the bottom, has the right container. The container is DB. But if you look at the another pod, which has a container auth, so this is the wrong things, because sometime what would happen, the service will redirect the traffic to the DB pod, but sometimes same service will redirect the pod traffic to the auth. So here you are getting inconsistency in terms of behavior of service, because either it should be auth or DV, because service should be having the only one dedicated service. It should not be not mixed. Okay, so this is not good. Why it has happened? Because the labels are wrong. Labels you did auth with the prod B 1.3, which is bad. So now if you look at this here, service has a two label, prod and B. I removed 1.3. So the moment you removed 1.3, any other pods which is matching with that criteria, prod and B, will automatically load balance. You see here, prod B 1.4 and prod B 1.3 pods also being load balanced because of labels are matching. So when labels are matching, then automatically service endpoints will get updated, because all services in Kubernetes work with the labels. If labels are matching, services will load balance the pod. If labels are not matching, services will not load balance a pod. Let me tell you one more statement here. Here, the label of service should not match with the label of pod. Here, label of pod should match with the label of service. Okay, understand that. Label of pod, if it is matched with the service, then service will load balance. In this case, label of pod, which is a prod B, matched with the prod B. That's the reason service will load balance these pods. Now here this pod, you are again getting the wrong thing. Because of what? This is because of only labels. You see here, you have a prod DV, pod DV, 1.3 version and 1.4 version, 1.3 to 1.4. So here service is redirecting the pod to the sometime 1.3, sometime 1.4. Again, this has happened because we labeled the service and pod in a wrong way. So what to do to fix it? Now it is good. Now it is good. So we relabeled service with 1.4. So from earlier it was 1.3. If you look at this, 1.3, but in this we labeled one wrong auth pod also. Here it was wrong because we labeled wrong because prod B, but here in a pod stuff which we have 1.3, 1.4. Now we did wrong, right? So now you see that here this service is redirecting the traffic to only the right pod, which is matching with the prod B 1.4. So service is a way to load balance your pod, and service is a way to direct your traffic to similar kind of pod. Now you can create as many services in your Kubernetes cluster, which is in a similar type. So now the question is, what is a service? So here if you see that service is a kind of load balancer which send the traffic only to the healthy pods. The pods which is running, they will send the traffic only to healthy pod. It can be configured for session affinity, and service can be internal and external. Means service can be created within for accessing the service within a cluster itself, or it can be created for the external communication also. The algorithm which works for this service is a random load balancing, and it uses TCP by default. TCP means IP address and port. So the question was, how can we access pods, multiple pods in a cluster which is running across multiple nodes? The answer is service. Service can be within a cluster or can be outside of the cluster. Okay. So any questions on the service front so far?
Hey Rajesh, Guru here.
Yeah, Guru.
So I have one quick question. So if you update this service with a new label, right, a new version of the label, then you also deployed new pods. So then if I don't point to the older version of pods, right, with any labels on the service, so what will happen to those pods if you leave them behind the scenes?
Okay. So there are 3 questions. First of all, let me tell you here, any object you create in Kubernetes, no matter whether it's a pod or service or deployment or application controller or anything, you try to label them. Label is not only is meant for the service to work, but many other objects. Like if you want to filter it out, something you want to list out by labels. Okay, you want to search some pods which is with the labels. So you can also do. Okay, you want to list out, you want to delete some pods with the help of labels. So that and all you can do that. But here the question was, I think, what about those pods where the labels are not matching with the service? So that pod is a waste pod. When it is a waste pod, you are going to delete it. So how you can search those pods by labels and validate whether these pods are accessible to any service or not. If it is not accessible to any service, you can delete. There is a command line also available to delete, and I'll talk about this in demo section.
I remember now.
And,
so the process is manual process to delete it. So it's not clever enough to go ahead and otherwise you'd use some kind of deployment strategies, right?
You can create a batching, I believe, batching, but right now I cannot tell you from with a surety, because I need to check that whether batching allowing the deleting of the non-use pod is allowed or not. I need to check.
That works, but the only thing is if the version updated, that's fine. I think I got it. So manually delete it. That's what we are doing now. Just want to check is there any automated way to delete it. Yeah, that's fine. The same way whatever you told, that's how we do it. Yeah, that's fine. Thanks.
So
sir,
here
I have a question around.
Yeah, Rajesh, I also want to have one question.
Yeah. Yeah, go ahead one by one.
Yeah, so this is Umesh. I'm saying, Rajesh, we do have a load balancer normally.
Umesh, your voice is breaking, I believe.
Yeah, so I was saying normally we do have load balancing mechanism. So normally we give this name directly load balancer, and we create load balancer. So why this specific name given to this? Anything additional from the load balancing we are doing?
Okay, so the question I believe is, we have a load balancer already. So why do we have a service here, and to make this load balancing works? And maybe second question is, why do we label it to make it work? Because load balancer can directly, we can pass the IP address, correct? Is that was that the question?
Yes.
Okay. So first thing, remember, the load balancer which you are talking about is completely working on a physical network. Okay, physical network, that means IP address of your node. Okay, remember this. You can look at the pod, and if you recall the discussion what we made in the previous session, pods is not on nodes network. Pods IP address is not on a node network. Pods get their own network. We call it pod networking. Okay, now there's a two network. Load balancer which you are talking about can only access the physical network. But what about the pods network? How can you load balance? And here you have interesting points. The pod you have in the pod network, and pod is across the nodes. So how can you load balance these pods IP addresses? And for this to handle, we have a cluster, scope service which is, you can create basically it's a load balancer which you can create for the cluster, and that can point outside of the cluster as well. Now here this load balancer can work with the cluster itself, with the pod networking. Now external load balancer also we need it. Okay, and if you see the third point, you are the one which you are talking about, external load balancer, we will use that external load balancer itself to the third point if you want to point outside of the cluster. But if you want to use inside of the cluster, your load balancer don't understand the IP address of the pod because it's not on physical network. So we need someone who can understand the IP address and of the pod, and at the same time they can divert the traffic. So for that we have a service. Am I making sense?
Yeah. Okay. Got it. Rajesh, one
Let
more
me,
question I
if
have.
you are confused, I can rephrase this. I can answer in another way if you are confused.
Yeah, if you can, please.
Yeah. So see here. Remember my discussion. See, load balancer which you are talking about is understanding this IP address, node IP address. We call it physical. This may be physical machine or virtual machines. Okay, this one.
No.
Now the pod which you are running is here and here and here and here. Now pods get IP address too. So X, Y, Z, M. This IP address is called pod IP address. Now these pods are accessible to each other. But if you are outside, let's say this is your load balancer cannot access this pod, cannot access this pod, cannot access this pod, cannot access this pod. But load balancer can access your this one. So for internally, let's say this is the 4 pod I have for the web server, which I represent in the slides also. Now there is a 2 database. So now this 2 pod is in same network. By the way, all these pods are in the same network. Now we need to connect from the database to here. But which one? Whether here or here. So here we got one load balancer, and now you talk to here, all this talk to here, and it will redirect to the here. So this is happening. This service will work. This load balancer will work on the pod networks only, not a node networks, which you are talking about. Is that clear?
Got it. Yep. Thanks.
Rajesh, I have question around as you mentioned, all the pods are database pod, but if I have different applications microservice pod, then how can I have one service to coordinate with all these pods?
No. In that case, you have to create, because I said very clearly, service you create for the pod which is matching in terms of behavior 100%. Okay, so you have to create a multiple services in that case if you have a different kind of pod. So if you see this image itself here, you might have created 2 services, one for the service which is for 1.3 and 1.4. So different services for the different kind of behaviors you should create. That's a logical.
And my external application should connect to application load balancer or this service only?
So you hit to the service, and service decide which pod is healthy, and let me redirect the traffic to it. So how the service will redirect the traffic? Because if the labels of the pod and labels of the service is matching, then automatically service endpoint is getting updated. Service endpoint means load balancer, you are adding those pod IP address. That is called endpoint.
So in this example, we will have 2 services, right? One for DB, one for
It is a
front
good
end.
idea to have a 2 service for this. So here you will have 1.4, 1.3. But whether it's up to you, whether you want really 1.3 to be running or you want to be deleted.
Okay.
Rajesh, one question I have. So basically, when some pods are unhealthy, right? They are getting destroyed, and the new pods are created. So how will a pod knows whether it is a healthy one or unhealthy one? Will there be any live checking between these pods with the service? Means my whole point is who creates the new pod, like who understands the health and who creates the new pod.
Okay, so if you remember that the who creates a new pod, remember that the monitoring is done by the controller. If you remember the discussion in the previous session. So controller, we have a controller at replication controller, and we have a controller at deployment also. So typically when you want the multiple pod, you use the replication controller or a deployment. And in that case, this controller will make sure the number of pods which you have desired should be available in your cluster. Okay. Now the question is who schedule the pod? If you remember, scheduler schedule the pod in case if the desire and actual is mismatch based on the API instruction. And API instruct based on the controllers reported. Now, who initiate a pod? Initiate a pod is done by the kubelet in a node, if you remember. Okay, so now we have to link all this together. So now this creating a pod, instantiating a pod is done by kubelet based upon the instruction from scheduler. Scheduler get the instruction from API server, and API server will get the instruction from the controller-manager. Controller-manager will check and keep checking in the loop how many pods is running and how much it was desired. So now this is the pod. Now your responsibility is to label the pod appropriately, because this is your work. Everything will be done by Kubernetes except labeling. And labeling, you can decide which you want to label. So you label it service, pod, deployment, replication controller, or any other objects. The service automatically detect and update their endpoints based on the matching labels. Make sense?
Thank you, Raj. I got it.
Okay. Any more questions, guys, here?
Yes, sir. One question. So you said that if I have multiple different type of pods, so I have to be configure multiple services. Then if these pods suppose that I have front end pod and back end pod and database. So then do I have to create one master service to coordinate between these sub services?
No, we don't need actually. You just think about it. In this architecture, how many you have two kind of pod. One is this one, and one is this one. So here in this communication only you need a one service. Okay. Now here you need one service, and here you need one service. Okay, and then this load balancer talk to this service. Okay, so how I'll talk about this one. But in this case scenario, you have two group of pods. So you needed two services in that case. One for the internal, one for the external. Got it?
No, sir. It's still confused with internal and external services.
See here, let me picture. So this is a one node of your cluster, another node. Now there's a two kind of pod. Let's say just simple thing. This is a front end. This is a front end. This is a front end. Now, and this is a back end. 1, 2, 3, 4. This is a back end. Now, front end need to talk to the back end. So, front end, remember, front end need to talk to the back end. So, here you need a service, right? So here
Asma,
front end. So here
प्याज और हरी मिर्च काट दोगे क्या? मेरे को पोहा बनाना जाते टाइम नहीं कर पाओगे?
yeah, we can do the poha things little later.
प्याज
After
कटा को
20
फ्रिज के अंदर रखना फ्रीजर में, उससे निकाल लेना, 3 हरी मिर्ची काट देना और धनिया काट देना.
Gaur Bhavani.
Yeah.
Prepare poha later, please. Okay. So here you see, this is the service. This is the one service. Now, because of labels of this pod is matching with the service. This service automatically load balance. So now here in this application configuration, when you want to traffic the front end, back end, so what you will do? This endpoint, this X, you will update. There's only one fixed IP address, so you'll update in the front end configuration file, API, Apache, or whatever. So from the front end, it will direct to the only one service. This is a fixed IP address. Now this guy will decide which pod it will transfer. So in this case, only one. But now the question is, from outside also, people will communicate. So here you have to create one more service. Okay. Here, this service will dedicate to the outside people. How it will talk to the load balancer, I need to talk about it. But here in this way, you created two services. But if you don't want that service to be available outside, there's only one service. Got it?
Yep. So now it is clear.
So last question, Rajesh. So this internal load balancing is totally done on tag basis, right? Tag or label, whatever we say.
Labels basis. Yes, it's completely label basis. So let me tell you the internals of it. What happens? You label it all the objects. Okay. Remember, service is your load balancer. Okay. Service is your load balancer. We just call it load balance. Service in Kubernetes. Okay. So what happens? Service needs what? IP address, because last point, if you read it, it uses TCP by default. It required IP address to transfer the traffic. So how this IP address, each service we get it? So basically what happens, very simple thing. There is a core DNS discovery service pod is there, okay, which is running in your cluster. So now this guy, core DNS, is keep discovering the new pods or the old pods which get updated with their labels. So the moment the updated labels is found, they immediately not only update themselves, but immediately update the service saying that, okay, I found out your class which is matching with your labels. So you take it. So service gets happy. Service says, okay, thank you. Okay, and let me add this new IP address which you have given it to me. Okay, because you have given it to me the IP address which is matching with my label. So let me add to the endpoint. So that is how core DNS empower the service. Make sense?
Yeah.
And this happens instantly, because the moment you change the labels, automatically service will get updated. I would show you during the demo as well.
Yep.
This label activity only done once we make any changes inside image.
No, labeling can be not done through the images. Labeling can be done through when you create a pod. When you create a pod using the kind is equal to pod, or you create a pod using replication controller or deployment.
All right.
Rajesh, what's the meaning of BE?
What is open?
What's the meaning of BE?
DB.
No, your
BE.
tag, Rajesh, BE. After prod,
Okay,
you have
I
a
think
tag.
you missed that lots of session, I think. So you have to go through the videos only, because these are the nothing but labels which you provide, which human provide to the pod, so they can categorize the pod for their services. So I think you missed lots of things.
Yes, I did.
Okay, so now let's move on to the next discussion of deployments. Yeah, I did that little bit of the deployment. Let me conclude that. So here, remember, replication controller will replicate, has a two feature, replicate a pod to X number of pods, and also has a controller. Controller will make sure the desire and actual is in act. Okay, so this is the replication controller. And this is a deployment. And deployment, as I said, has a multiple feature. If you look at this, what most of the important feature is, deployment has a feature of replication controllers as well for the version 2. Okay, so deployment has a feature of replication controller. That means it can replicate to a number of pods, and same time controller which will make sure the actual and desire is matching. Okay, that is one thing. Now deployment can be versioned as well. Okay, that is a good thing about it. Version means any changes you make to the deployments, automatically it will be version. It's like a Git. So you don't have to go through again, earlier code which you had, and then because cluster also you will do the versioning. Okay, that is a feature which you have. Now this version will help you to the simple rolling updates and rollback also. Okay, so you don't waste time here. So this rollback will help you for simple version and rollback as well. Okay, so deployment is a very good, and everyone in your production, we use the deployment itself. Okay, so these are the, so here you see multiple concurrent version, this rolling updates and rollback, and powered with blue-green deployment, canary releases, simple version rollback, and all this thing it can be powered with. Okay, so now the time has come to just conclude the discussion, because we have had a lots of discussions from last 3-4 sessions, and let's conclude. So yes, ultimately we, as part of the discussion, we have a master, and master has a 4 component if you look at that, and we discuss all these component in detail, and then master manages the nodes. Okay, here you can have a multiple masters, which I will talk about it, setting up the multiple master, how can it works, and how can you set it up and how it works. But for HA, for the discussion sake right now, and this multiple master, but one is active at a time. And then here in the master, you have a 4 component. One is API server, cluster scheduler, and controller manager. I discussed about the behavior of each of it. And then you have a nodes. Nodes also are minions, and nodes has a 3 important component: kubelet, which is a main Kubernetes agent, and Docker engine, which is a Docker or RKT, and kubeproxy, which is a Kubernetes networking services. Okay. We also discuss the objects, the few objects only of the Kubernetes objects, which is pods. And now we understand the pods in detail. Atomic unit of scheduling in Kubernetes. If you want to scale the pod to many, then use the replication controller. Controllers makes the actual and desired state. Then we have a deployment which has a RC. RC means replication controller, plus many other features like rolling updates and rollback, and services, which is for the stable networking and load balancing for the pod. Okay.
Hey, Rajesh, I have one quick question.
Yeah.
Just if we go back to the diagram, right? So regarding the infrastructure nodes, is something is only specific to the OpenShift or other Kubernetes service providers, or is it like part of the naked Kubernetes installation process? The infrastructure.
So infrastructure node is just, it can be physical machine or it can be VM. Now, the VMs can be created through any number of ways. So it depends on how you use it. You can use private cloud, public cloud.
No, I'm talking about routing infrastructure nodes like HA proxy, where HA proxy install, that will do the load balancing for Kubernetes services.
Can you reword your question, because I'm not getting it?
Okay. So usually, right, in like present OpenShift cluster installation process, okay, it's the Kubernetes services, right? So as part of that, we have master nodes, and we do have some infrastructure nodes, and we do have some compute nodes. So the compute nodes, what you are talking about, minions and stuff, and then we do have master nodes, and we also have some infrastructure nodes which has HA proxy installed there that is going to take care of the routing to the nodes. It's not something related.
No. Kube proxy. Okay. Hold on. Kube proxy is always installed in the each node. I said each node of your cluster. The node which belong to the role of nodes or a minions or a worker or master, because proxy is your networking services. In a simple word, I'll put it now. I'll show you that during the discussion, during the demo as well. In the simple way, if I put it now, proxy is like your a bridge which provide the IP address to the pod. Okay.
Okay.
If you know the Docker, in a Docker 0, you know the Docker 0?
No, don't have.
Docker 0. So yeah, so I would request you go through the one of my video on the Docker networking topic, which is a 1 hour of recordings, and I think you have access. So get it done today only, and in that you see what is a Docker 0. Docker 0 is a bridge which manages the container's IP address. So something similar, Kube proxy manages the pod's IP addresses.
Okay. You're talking about bridge network and
Yes.
Yeah, I do overlay network, right? Yeah, I do aware of the. Yeah, I got it. Yeah, clear. Okay, thanks.
Yeah, so it has to be in each node of your cluster, whether that node is performing like a worker or a master. Without this will not talk. The pods will not talk to each other. Not any pod, but in fact, the master component will also not communicate with each other.
Okay. Clear. Yeah, thanks, sir.
Rajesh, does
Yes.
master have kube proxy as well?
Master has a Kube proxy as well. Yes, that's a good point. Yes. So during the discussion, I have not said master has a Kube proxy, but I wanted to show you during the demo why this Kube proxy is everywhere. Because remember, these components which I talked about, which is called the API server, cluster store, scheduler, and controller. Remember, these are not of physical services. These are running in the pod. And remember, pods get the IP address from where? Proxies. So yes, in the master also you have a proxy, and I will discuss during the
Hello. So, kubelet and container engine, are they in master as well?
yes, of course, yes. Remember, yeah. So now you can correlate the things. It's like this. First thing, API server, cluster store, controller, and scheduler is not a physical services. It is running inside a pod. When it is running inside the pod, who can create and instantiate a pod? Kubelet, yes. So kubelet has to be there. Now, who give the IP address to the pod? Kube proxy. So Kube proxy also has to be there. When now your pod has a what? Container who is powered by container engine like a Docker. So yes, Docker has to be there. So basically, yes, I did say master has a 4 important component, but each component is powered by kubelet, container engine, and Kube proxy also has to be there in the master.
Okay. So now, how does kube proxy talk to services? How do they work together?
Yes, Kube proxy managed. Service is managed by Kube proxy. So that is what it happens.
And services is the
load balancer.
Is the load balancer?
Yes.
Okay.
For the pod networking only.
Okay. What about for replication, replica set and deployment?
Yes. So basically, pods for the service is the load balancer, which manages the load balances the pods. Now, pods you may come from the replication controller or deployment.
Rajesh, your voice is breaking.
Yeah, so I said service is your load balancer, and load balancer balance your pod. That pod you may create using deployment or application controller or client pod.
Okay. Yeah, thank you.
So I think if you go through the video once again, probably you will get the more context.
Okay.
Okay, so now these are the objects which we discussed about: pods, replication controller, deployment and services. And then let's see that these are the behaviors of the controllers which we have discussed. Create and manage a pod for you, define a desired state, respond a pod state and health. Replica set manage the number of replicas, and deployment manage the rollout of the replicas and stuff like that. So the question is, how does Kubernetes add persistency to this ephemeral behavior? So that is done by the services. So services add persistency to our ephemeral world. It's a networking abstraction for the pod access. Services has IP and DNS name. Again, redeployed pod automatically get updated to services. Scaled by adding and removing pods, it can be done, and some load balancing services. So ultimately, we have concluded the discussion of Kubernetes and all the building blocks which is needed, you needed to understand in Kubernetes. I have explained it, and now onwards we'll get into the installing a Kubernetes. So that is our next topic. So from now onwards,
sorry sir, disturb you. Sir, I was asking in earlier section that context mapping things that maybe I miss, or maybe we need to bit discuss around that. What is it and how, where it is used, context mapping in Kubernetes?
Context mapping, which you are talking about? I am not able to understand.
I'm not much sure, because somebody in some interview asked how to do context mapping in Kubernetes. So that was in my mind from long.
No, I think it's not a complete question. So can you do one thing? Recall these questions properly and do drop me an email for it, probably, and then I will see that. Okay?
Yes.
So your question here is, how does Kubernetes add persistency to all this ephemerality? What's the answer to that?
So here, what I was trying to tell you here, pods are ephemeral in nature. Pods will be replaced with the new pod. Okay, if the one pod dies, another pod will come. The here is, if you look at this, another pod will come, you will get the new IP address. So it is not persistent, it is ephemeral. But the question is, how can you access the pods in a persistency way? And that is where the services comes. Services, you hit the service, okay, you hit the service will make sure that one of the pod will be available for you, no matter the pods is coming and going. For the service, you are getting the traffic to the healthy pods only. So that is called pods persistency. But again, storage persistency is another topic which we need to discuss again.
Okay. Yep.
Okay, guys. So yes, this is the end of our discussion, and then this session as well. So tomorrow onwards, we are getting into the installing the Kubernetes. So now I think next few days, I think 3 to 4 days, we will have less slides, no slides, and we will get into the how to doing the thing. Okay. So we will set up the Kube-ADM. Installing the Kubernetes you can do through many different various ways, but we will do through the Kube-ADM, which is required in the CKA course, okay, certification course. So that is what we will do, and then we'll get going. So from tomorrow onwards, we'll get into the demo part, and the recordings would be available for the lab, which you do in the offline. So now my request would be to everyone, please go through all the recordings, 4 recordings. I think we have made it. for this topic so far. So you go through in one go itself before tomorrow. Okay, so tomorrow you should not ask conceptual question, because if you go through that, probably you get a clarity and then you will not be having that questions anymore. Now, yes, if you want to go and prepare more for the questions which I'm going to show you the demo with, for that you have additional videos as well. If you have a time, you can spend more time on that as well. So these videos are already available in LMS. You can go through that and check. Okay, guys.
Thanks for watching. I hope you enjoyed and learned from this video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.